This is going to be 6-2 and 6-3 combined, talking about quadrilaterals. So any polygon with 4 sides is a quadrilateral. But some quadrilaterals have special properties. So we have something that's called a parallelogram. A parallelogram contains 2 pairs of opposite sides that are parallel to each other. So remember, these symbols mean parallel to each other. It does not mean that the lengths are congruent. Here are some properties of parallelograms, some things that you need to know. In a parallelogram, the opposite sides are congruent. So even though it's not stating that, based on those symbols, if we put those lines there, that side's congruent to that side, and this side's congruent to that side. In a parallelogram, for the next one, opposite angles are congruent. So notice that they're marked here for you. Angle B is congruent to angle D, and angle C is congruent to angle A. In a parallelogram, consecutive angles are supplementary. What that means is that consecutive is right next to each other. So right in a row, like angle A and angle D, they add up to 180. They're supplementary. Okay, so any next to each other, D and C, add up to 180. In a parallelogram, diagonals bisect each other. What that would tell us is if they bisect each other, then AZ is congruent to ZC, and BZ is congruent to ZD. So we can use these properties of parallelograms to help us find out some information. So remember some things we know about parallelograms. The opposite sides are parallel to each other. The opposite sides are congruent to each other. The diagonals bisect each other. So they create congruent segments. So if I know all of that, and also that with angles, the angles, opposite angles are congruent and the consecutive angles are supplementary. So knowing all that, let's see what they tell us. A running track CDEF in the shape of a parallelogram has side lengths DE is 74. So if I know DE is 74, I already know CF is 74, which happens to be the first question. And DG is 31. So DG is one of the diagonals, half of a diagonal. So I also know that GF is also 31, and I would know that DF is 62. So let's see if it asks that. It asks DF, which is going to be 62. And then the angle measurement FCD is 42 degrees. So a couple of things that I know. I know that the angle opposite that is 42 degrees, and I also know that angle CDE is going to be subtracted from 180 180 minus 42 to get that angle. So if we want measure of angle EFC, which is consecutive with 42, so I would do 180 minus 42, and the answer is 138 degrees. Try the now you try, hit play when you're ready to see the answers. Notice I marked up the figure so I could figure things out, and those are my answers: 48, 107 degrees, and 30. Example 2, using properties of parallelograms. So we know that consecutive angles are supplementary. So I know that 9b plus 2 plus 18b minus 11 is equal to 180. So then I can solve that. 27b minus 9 equals 180. 27b, add 9 to both sides, equals 189. Divide both sides by 27. So b equals 7. Oops, that was for the measure of, that's going to help me with the measure of angle Z. I did that in the wrong spot. So 9 times 7 plus 2 is going to be 65 degrees. So that was for B. And now to find YZ, YZ is right here. I know that opposite sides are congruent. So 8a minus 4 is equal to 6a plus 10. Subtract 6a from both sides. 2a minus 4 equals 10. Add 4 to both sides. 2a equals 14. A equals 7, so to plug that in for YZ, then I would do 8 times 7, which is 56, minus 4 is 52. YZ equals 52. Try the now you try, hit play when you're ready to see the answer. Here are the answers to the now you try. So sometimes you can tell if something is a parallelogram without having all of the information. So here are some shortcuts. If you have a quadrilateral with one pair of opposite sides parallel and congruent, then it's a parallelogram. So it would look like this scenario. If you have a quadrilateral with opposite sides congruent, then it's a parallelogram. So we saw that one last time. If we have a quadrilateral with opposite angles congruent, that congruent, then it's a parallelogram. If you have a quadrilateral with angles supplementary to consecutive angles, so meaning like if this one's 20 and this one's 160 or something like that, if they're consecutive angles, then you would have a parallelogram. And if the quadrilateral has diagonals bisecting each other, as shown by these, then it is a parallelogram. So we need to show that JKLM is a parallelogram if A is 3 and B is 9. So if you plug those in, if A is 3 and B is 9, I plug those in to the sides, and those are the measurements I got. So I see that my opposite sides are congruent to each other. So this is a parallelogram because opposite sides are congruent. So for the now you try, plug in 7 and 4. So when I do that, I get 21 here, get 21 there, plug in 4 here and I get 16, plug in 4 here, I get 16. So the opposite sides are congruent. So this is a parallelogram. Show that EFGH is a parallelogram for Z is 11 and W is 4.5. So let me plug those in. So for example B, when I plugged in my values, I see that my consecutive angles are, these ones are supplementary and so are these. And so therefore, since consecutive angles are supplementary, then this is a parallelogram. So in example 2A, we have consecutive angles are supplementary. Let's just abbreviate, consecutive angles supplementary. So that is a parallelogram. In example B, we only have one pair of opposite angles congruent. We need both pairs to be congruent. So this is not enough information, so it's not a parallelogram. No, only one pair of angles are congruent. We needed two pairs of opposite angles to be congruent. So determine if these are parallelograms. So this one is a no, because we need the opposite sides to be both parallel and congruent. So if these parallel signs were here, it would have been a yes. So there's not enough information for that one. And this example B is a yes because the diagonals bisect each other.